Okay, so I've given a number of Hanover seminars over the years. This is going to be the most different one I've ever given. There's going to be very little forest biometrics in this. And this is, I'll show some results from some work, but it's actually going to be more of a prospective talk because a lot of this is ongoing activities rather than published or completed activities. Okay, so hello. Advance. Or not. I think it fell asleep. I just shut it off and on again. It's just gonna make it work. I could just advance by hand.
Yeah, you want to do that one.
Or, okay. See if that works. No, it's not advancing. Ah, okay. Thank you. I think you figured it out. Okay. So what I'm going to talk about first is conservation of the Mayan Forest. This is probably a place that not a lot of people know about. It's about 10 million hectares in Mexico, roughly in the area that's circled. It turns out it's the second largest area of tropical forests outside of the Amazon in the Americas. And it's home to Mesoamerica's largest indigenous population and sustains thousands of indigenous families and farming communities. Now, the Yucatan Peninsula of Mexico is losing forest cover to high input, low diversity agricultural systems. This is threatening indigenous biodiversity, and it's causing a loss of indigenous knowledge and traditional livelihoods. You can see we have North Carolina style pig farms going in, miles and miles of maize. Here's a graph showing the increase in agricultural land and the decrease in forest cover over time. Now, many of you may know that modern ag, big ag, is high risk, high input for farmers. And it also degrades the environmental quality and the quality of health. An interesting statistic I learned at Michigan State University is that American farmers have among the highest suicide rates of any profession. And also farmers in the Yucatan have high rates of suicide. So there's something wrong when farmers are committing suicide. You can also see that modern farming, in the modern way we produce food, is not only unsustainable, but it's bad for human health. Now, the government of the Yucatan is aware of these problems, as is the government of Mexico. They have ambitious goals for net zero deforestation. But the problem is there are these competing needs for food production and forest conservation. And there's also concerns about impacts on indigenous farming practices, which I'll explain in a little bit. This is really the focal area of this research we're doing down there, which is sort of this conflict between forest conservation and sustainable food production. So looking for solutions and how we might have our forest and eat it too. Many of you are familiar with, and the theme of this series is, forests for climate change. Many of you might be familiar with the UN REDD program, which stands for Reduced Emissions from Deforestation and Degradation of Forests. Mexico has its own REDD program. And here in the Yucatan, you can see the zoning map for sustainable production associated with conservation and climate change. If you look at the third item here, this is the zoning map that can identify areas for potential planning and aligning with public policies. Okay, another is a monitoring system focused on observing the Mayan Forest. And you could see back in 2016, these are the three governors of the 3 states of the Yucatan, which make up the Yucatan Peninsula. They signed an agreement basically for sustainability and outlined these goals. Relevant to what I'm talking about is stopping, reducing deforestation, promoting Mayan biocultural landscapes, and also restoring the coastal areas, as well as, doing their role for global climate change. So in this work, there's both research and education opportunities. The real focal point here, you can see in all these pictures of people in action, it's all about connecting the forest and trees to food and medicine production and healthier lifestyles. So we're focused on high-value agroforestry products, recognizing indigenous knowledge, empowering local communities to control land use decision-making, and emphasizing connections between forests and human well-being. There's also an education component, which I'll go into more towards the end of this. And this is when I'm down there just talking to people, there's a large number of problems that are related to forests in the Yucatan, but they don't have a lot of expertise in forestry. That's actually through a weird series of events. That's how I ended up down there. And while I was down there and just talking with people, people kept saying, oh, we need your expertise. We need these ideas, So there's this big need, there's this big gap really between the educational capacity for forestry and sustainable forestry and the demand for that type of knowledge. I'm also going to talk about at the very end about a new study abroad course that I'm working on. So as Raju mentioned, as my career sort of takes this strange turn, I am now the director of the Institute for Ecology and Human Wellbeing, which connects the Department of Forestry at Michigan State to the Institute for Global Health. One of my chief collaborators is Dr. Travis Gordon, who's a doctor of osteopathy, and he's also now completing a master's in psychology. And he's actually been helping to introduce the field of osteopathy into Mexico. Mexico does not recognize osteopathic medicine as a legitimate form of medicine. But we have special license, Michigan State University does, the College of Osteopathic Medicine, to practice in a hospital in the Yucatan. And so Dr. Gordon is working down there. And he's also very active in this whole idea of sustainable lifestyles, connecting basically the environment to human well-being. And so he and I have formed this nice collaboration. We're also collaborating with the government of the Yucatan. This is the Saida, who's the Secretary for Sustainable Development, and Gerardo Vela, who's the Assistant Secretary for Science and Higher Education. Then we also have the Universidad of the Yucatan, which is the Autonomous University of the Yucatan in Spanish, and Sinvestad, which is a big research institute. This is my colleague, Dr. Javier Quezada, who's an expert on bees and apiculture and pollination. And this is Dr. Jorge Herrera, who's actually a global leader in mangrove restoration, and particularly an expert on mangrove restoration in the Yucatan of Mexico. So we've got this very strong team together now, and we're working on these interdisciplinary projects in the One Health framework. And for those who aren't familiar with that, One Health concept is that people, animals, and the environment, all our healths are interconnected into this one global health that we cannot escape from by compartmentalizing our health or the health of animals or the health of the environment. So we have to look at them as synergistic. Okay, so with that introduction, I'm going to talk about something called analog forestry systems. This is basically a form of silviculture that very few of you will have heard of. Matter of fact, there's almost no published papers on it. Sort of ended up buried in the literature. Analog forestry systems are analogous, that's where the term comes from, in structure and ecological function to the original forest vegetation. So they aren't the original forest vegetation, but they're analogous in structure and function. And the idea is to strengthen local communities, both socially and economically, with tree plantings of high biodiversity. And these are chosen to provide not only commercial products and resiliency, but also specifically to avoid fossil fuel use and agrochemicals. So organic, low carbon impact. So it's just a very focused form of agroforestry to a certain extent. This is a really nice graphic that I've been using to explain this. And so you can kind of think of all the ways that we might do agriculture or conserve natural forests. So this is agriculture. We add some trees, we get agroforestry. We extend the rotation and increase the structure, we get permaculture. On the other end of the spectrum, we get sort of the natural forest ecology. So going this way, we have increasing structure and more natural structures and functions of forest. Going this way, we have increasing loss of tree cover and decreasing crop age and diversity. And analog forestry is right in here. So there's a lot more trees and a lot more vertical structure and biodiversity than you'd find in a typical agroforest system, but less so than you'd find in a natural forest. So it's somewhat of a compromise between trying to maximize the values of both of those. So I became really interested in this after going down to Ecuador. And there we met Raul Ramos, we meaning Lauren Cooper and I. And then we got involved in this paper, which was published in Forestry last year, the carbon sequestration potential of analog forestry in Ecuador, an alternative strategy for reforestation of degraded pastures. So Lauren and I liberated this excellent work by Raul from Spanish. These are some friends I made who work for basically forest government extension in Ecuador. This is kind of what a natural forest reserve looks like in the place we're working in Ecuador. And so in a lot of places, the forests have been cleared and a pasture is created, and the pasture eventually gets degraded over time. And so if you want to restore that to a forest, a typical option is to put in some kind of a commercial plantation like Teca, Tectona grandis. But Raul and his colleagues were also looking at analog forestry systems, right? So you're planting a lot of different types of trees and shrubs as opposed to just one type. Here's a table from our paper, just to give you a sense of what was planted. So you can see that the growers didn't want to give up teak completely. It's a very useful tree species. So there was actually teak in the analog forestry system. This other species, Cordia alodora. I actually had a student, Tina Guo, maybe some of you know her. She did an independent study with me, and we did a little project down in Ecuador where she was looking at the drought resistance of this species. And this is the wood it produces and the flowers. It's a multi-use tree that's indigenous in tropical Latin America. This species, Piper aduncum, is basically a shrub. It's like a pepper bush kind of a shrub. You can use it for spices, and it's also used medicinally and for tannins. And then many of you probably know Theobroma cacao. Theobroma, aptly named, means food of the gods, which is what the Latins considered chocolate when they found it. And cacao is cocoa. If you've never seen, that's a cocoa pod. Those are the cocoa beans and the cocoa butter on the inside. That's where chocolate comes from. So anyway, you can see this is mostly diverse tropical timber species. You're getting a multi-layer canopy, and you have some medicine, and then you have some food, but you have this very complex architecture of this forest. You're trying to mimic the structure of more of a natural forest, have biodiversity and useful products in it. So this paper really asked didn't make any judgment on the difference between this and teak, but basically asked what was the difference from a carbon sequestration perspective. So 17 years later, so basically you have this degraded pasture. The degraded pasture is sort of just let to go through some kind of natural succession to grassland, or you plant teak trees in a plantation, or the analog forest system, which I explained before, and you could see the results. Basically, the analog forest system had actually the highest total carbon storage. It wasn't statistically different from the above ground portion from the teak plantation, but there was a lot more carbon sequestered in the soil. And the hypothesis here is that the microbial communities and everything in there are much more diverse. And also you get better protection from erosion and things like that. This was really interesting, and this is documented in another place in the literature. The teak plantations were actually mining carbon out of the soil. So they actually had lower below ground carbon than the degraded pasture did. And they were putting it into the above ground. So this was really interesting. And so the good thing that was shown by this, and this paper is starting to get cited now, is as an alternative to strategy for degraded pastures, is because it gives the landowner more options, more of a diverse portfolio of products to have. And also we can get a bigger carbon benefit. And so just want to emphasize that this research focused on the carbon storage as being important, but there's really a lot of other potential benefits associated with this. So when fate brought me down into the Yucatan, and I started looking around down there or driving around and meeting with people, I started thinking, you know, this analog forestry could work really well down here. And as a matter of fact, the Mayans kind of invented analog forestry. It's a book I just finished reading called The Mayan Forest Garden, 8 Millennia of Sustainable Cultivation of Tropical Woodlands. This woman, Annabelle Ford, has worked in Belize for many years. She's an anthropologist and actually is a friend and colleague of Gloria Medina, who runs the Center for Latin American and Caribbean Studies here at MSU, which I found out recently. Anyway, the way the milpa system works, you've probably heard of slash and burn agriculture in the tropics. So what they do is they have a forest and they clear part of it and they plant corn and maize and beans, the three sisters, and other crops. They clear a patch of the forest and then they let that grow back. And they don't just let it grow back through random succession. They actually cultivate the forest like a very complex garden. And so this was, to me, it was this is analog forestry, what they're already doing. And so when I started thinking of how might you modify this for a little bit to enhance carbon capture and climate change, this diagram here, this is sort of the regular milpa system, which really goes from agriculture, cycles through to analog forestry and back again. But you might extend the rotation age and sort of shift it a little bit more towards carrying it further and towards natural forest ecology. This is Lorena. She's from the Yucatan. She's wearing her Spartan hat there. This is Don Francisco, who's the leader of this community in Yaxuna. That's a milpa. So we went down there and we're just discussing these ideas with people in the community and seeing what they thought. And so the main thing that they really would need to do that is they would need some product coming out of the forested part that would really enhance their income and maybe produce some food or medicine or something like that. Okay, so one of the questions was, what forest crop could we add into this system to extend the value of the forested part of the system? And we came up with organic forest-grown vanilla. These are vanilla pods. Vanilla is an orchid vine. It's the only orchid that produces an edible fruit. There's 110 species worldwide. 5 are endemic to the Yucatan, including the main commercial species, Vanilla planifolia, or Mexican vanilla. I have a prop. This is organic Mexican vanilla. You can smell it through the package. Had to be sealed like that so customs wouldn't take it away from me. Interestingly enough, so basically you cure these pods, and that's where you get your vanilla beans from. And that's when you cure them, you basically, and dry them in a certain way, you sort of drying and fermenting them. That's when you bring out the aromatic oils in them. So this graph is showing the value of silver versus the value of cured vanilla pods. And you could see right now, vanilla is about worth its weight in silver. So an extremely valuable product if someone could get a very high amount of income with a very small amount of this. That's something like, I don't know, a lot. That's like $50 worth of vanilla or something like that. Now, the world demand is greatly exceeding supply, which is also driving this pattern. So in a lot of these traditional systems, especially where these indigenous people are, they derive their own medicine from the forest. For some people, it's like 3 hours to drive to a public hospital. A lot of these Mayans are quite poor, and they have a long history, millennia, of using the forest for different values. There's really a large number of values reported. These have been, like many of these sort of aromatherapy or these type of things, some of them have been more or less tested and put to sort of peer-reviewed science, but people use them anyway and claim they work. Dr. Gordon, my collaborator, he's really interested in this. He's kind of digging into this side of it. One of the avenues that we're looking at is there's actually some evidence that it helps premature babies to breathe if you give them, they inhale the vanilla, and it has some value in sort of the perinatal health. I told you I'm working on a study abroad. We're going to collaborate on a study abroad to sort of bring medicine and forestry together. But this is a study abroad that's being offered next spring break by the College of Osteopathic Medicine, Global Health in Mexico, Community Medicine, and Maya Culture in the Yucatan. So his group is working on this. Vanilla has quite a colorful history, romance, war, you name it. Vanilla is Mexican. Cispic in Mayan is indigenous to the Yucatan, but it's no longer cultivated there at any significant level. The place in Mexico where most of the vanilla comes from is in Veracruz. Now everybody knows about good old Cortez, who came and conquered various parts of Mexico. Cortez loved vanilla and chocolate, had them served to him together. European empire became fascinated with vanilla. And so they took the vanilla cuttings and they brought them all over to tropical parts of their various empires, but they couldn't get them to produce pods. Why? So, Edmund Albius, was a 12-year-old boy who was enslaved by a French botanist on the Isle of Bourbon, which is now called Réunion. It's a tiny island off the coast of Madagascar. And this is a picture of him as an older man here, but as a very bright 12-year-old boy, he actually figured out how to hand pollinate vanilla. Basically taking a couple little sticks and pollinating the flowers. Mexican vanilla is now grown all over the world, mostly in Madagascar and Réunion, about 75%. And almost all the vanilla in the world is produced via hand pollination. So, what are the opportunities and issues with vanilla production? Vanilla can be grown intensively, like this, or it can be grown in the forest, like this, which is sort of more the natural way that it grows. There's Travis and I with a grower in the Yucatan. He's very happy to show off his vanilla. I found this very recent paper in Ecosphere, which basically talks about these different strategies. Here you can see, this is called the land sharing model in their work. And so basically by giving some of the land for the intensive cultivation, you can protect some of the forest. If you grow it in the forest, they call that land sharing. This is land sparing, land sharing. And then they're talking about combining the two in the landscape and maybe even getting some pollination back and forth. Well, the pollinators here are people. On this other paper, this was just published last year, so people are starting to look at this now. So many of you are probably familiar with the two big crops, shade-grown crops that are in high demand worldwide in the tropics are shade cacao for chocolate and shade coffee, right? So those are two products that can be grown in this somewhat like an analog forestry and agroforestry environment. So this group did some research looking at vanilla and actually compared in their paper to coffee and cacao. And basically, because vanilla grows literally up the trees and is not as intrusive, and you don't have to cultivate as intensively, it seems to be the lowest impact on the forest itself in order to cultivate. So these ideas together show, and the value of it show a really good promise for this as a shade-grown forest conservation crop to increase the value of these forested lands, help the local communities, and fight against deforestation. However, there's two big issues for producers. They have very high labor costs. This hand pollination is up to about 40% of the cost. So vanilla flowers sequentially. So a flower opens for one day and then it closes. And then another flower opens for one day and then it closes. So you have to hire a group of people to be out there for weeks and just out there hand pollinating each individual flower. So this is very expensive and it deters a lot of people from getting into the vanilla game. You also have to know how to dry this properly. The beneficio, which is basically the artisanal process of drying it. You have to know how to do it and do it right. I'm actually in the Yucatan, which has a lot of hot, sunny days. One of the beneficios told me that there's actually a benefit to growing it in the Yucatan because you can process this faster and reduce the drying and curing costs. So if we could somehow reduce the cost in a more environmentally friendly way, that would be what we're after. And so digging around in the literature, we found the answer, or an answer, maybe, to bring back the orchid bees. So it turns out that this orchid bee, we now know from these very recent papers, there's a lot of question, like before hand pollination, where did vanilla beans come from? This is the secret of the Mayan and the Aztecs, is they let the bees do the work for them. So basically drove a lot of these bees and this relationship locally extinct. So what we're going to do, or what we are doing, is we've already identified areas to look at vanilla growth under different levels of canopy cover in different structures. This is Dr. Quezada. I took this picture. We're in a little tiny village called Yaxuna in an open air. He's giving a PowerPoint presentation in this little tiny room that's open on all sides. Anyway, he's explaining the idea to this community who were very excited about the idea. And Dr. Quezada's graduate students have been building these tiny little boxes. I like this one here. It's very artful. And inside these tiny little boxes, they're learning to rear these bees. So we're going to teach the community. Actually, next Monday, we're bringing members of the community down to a workshop at the university, and they're going to learn how to do this. They're going to learn how to keep the bees. And then we're going to introduce the bees back into the vanilla and try to recreate this historical mutualism, essentially, and maybe possible eat into the cost of producing the vanilla. Many of you know that my work with biometrics, I'm very interested in structural complexity of trees and forests. So I intend to actually bring the laser scanner down here and scan these analog forestry systems and try to look at how structural complexity affects both the growth and yield of the vanilla and the different mutualisms that might form. Now, we're also in the experimental design, we're going to have different tree and shrub species mixtures to feed the pollinators, because the vanilla doesn't flower all year round. So these orchid bees have to eat something else. So there has to be other pollen and nectar resources for them. And so we're going to try to look at what different species mixes in the analog forest system would help be synergistic with the survival of the orchid bees year round. So this is Adriana Gaia, the master grower of organic forest-grown vanilla. She has her own business. So we're hiring her with project funds I have to be a consultant. She's going to be training the communities and giving them 6 months of tech support, 9 months of direct monitoring of the vanilla, and then 2 years of virtual monitoring. It takes 3 years before the vanilla plants will flower. So we're going to be introducing the bees into existing vanilla plantations, as well as planting new experimental systems. Vanilla, you can just cut it and stick it in the dirt and grow it, but you really don't have to take care of it. So she has created a whole line of vanilla products. This is vanilla perfume. I'm going to pass this around and smell it. You know, the Yucatán of Mexico gets a lot of tourists to come down and see Mayan ruins and everything. The ecotourism can have an impact, but if these communities can basically generate a bunch of vanilla products and in a sustainable way, organic vanilla products, could be a big income source for them, as well as an interesting way to just increase the value of the jungle, the forested land. That's Dr. Gordon smelling one of those vanilla packages I sent around before. Okay, so I'm going to switch gears a little bit, because that's not all. So we're also doing something in the mangroves. So mangroves are a globally critical ecosystem, protect the coast from storms. I found out when I was down there from Dr. Herrera that about 80% of all commercial fish and seafood have their nurseries in the mangrove forests. So when I'm down there eating ceviche and all these delicious seafood when I'm there, the big draws to keep going down is if you need the mangrove forests to protect all of those species, they come in here and they breed. And then they go back out where the fishermen catch the adults. There's also a number of papers now, one that was in Nature back in the mid-2000s. They basically estimated that mangrove ecosystems have the highest carbon capture per unit area of any forest ecosystem in the world. And that's a lot of that is carbon going down into the sediments in the estuary. So the estuary captures huge amounts of carbon in the soil. The above ground mangrove system doesn't capture as much as, say, a number of other types of forests. So there's just a huge number of reasons to protect mangroves. They're also very important for Mexico. Mexico is fourth globally in mangroves. You can see in this diagram from Dr. Herrera's paper, all the different places there are mangroves. And the Yucatan has about 60% of all the mangroves in Mexico. You might not have heard this term, but this term called blue carbon. So blue carbon is carbon associated with these sort of coastal and aquatic ecosystems. And so mangrove conservation is a huge part of the whole conversation about blue carbon. I worked a little bit when I was in Kenya in mangrove, and so I'm going to be bringing my laser scanning equipment down to Mexico so we can get non-destructive allometric equations for the various mangrove species that grow down there as part of the collaboration. So mangroves are in desperate need of protection. You probably know this. About 30% of the mangrove forests in Yucatan have already been lost due to urbanization and coastal development for tourism. This is a recent paper from the Journal of Coastal Conservation. What I'll call your attention to is the term Mayan Riviera. Okay, think about that. So it's basically from Cancun all the way down and all the way across. And it's just big hotels, and you can imagine American, Canadian, European tourists going down to get drunk. Yes, and then changes in drainage and salinity. I was actually down here in October when this was going on. So basically this is in Salam de Bravo where we're doing the work, and they just wanted to put a new highway in to expand tourism there. What happens when you put a highway in is you disconnect the fresh water and the salt water, and you just wipe out basically the entire hydrology of the mangrove ecosystem. Mangroves are sensitive to the effects of climate change. So this is it's kind of like a catch-22, right? So if we know that mangrove systems protect the coastal areas in the tropics from the impacts of climate change, but they're also sensitive to them at the same time. So it's a very delicate balance. Sea level rise changes, salinity, extreme storms, increased waves, air, sea, temperature variations. So really keeping these systems in the balance is extremely important for both coastal protection and for our seafood. This is a cartoon Dr. Herrera uses, which I borrowed, which kind of explains the cognitive dissonance being experienced by people developing along the ocean. All right, so what can we do? So I'm working with a genius of pollination and an world expert on mangroves. So we came up with mangrove honey. So basically, I made the connection between these two scientists and came up with this idea. You should know that Mexico is the 8th largest producer of honey in the world, and the Yucatan region is the largest producer of honey in Mexico. I actually got sucked down there because a group from MSU, entomologists, we have a kind of a core group in MSU entomology who are experts on honeybees, were invited down there. And when they were down there, someone said, we really need somebody who has expertise in forestry and international experience. And so the government of Yucatan invited me down there, and that's how I ended up starting to work down there. Here's, that's me, the first time ever wearing a bee suit. This is Megan Milbreath, if you know her. She runs the extension honeybee at MSU. And Zachary Wang, who's been studying that tracheid mite for MSU for years. This is MSU entomology plus me. These are Africanized bees. So while we were there, first time in this bee suit, they're literally going like, bzz, 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 trying to sting my face. And one of the people got their hood hooked on a branch and ripped off. And I saw someone take 100 stings to the face. These are vicious bees. They have great honey producers, but it wasn't a lot of fun without the suit on. Dr. Quezada wrote the book on stingless bees of Mexico. So there are bees, social bees, which don't sting and produce honey. Isn't that great? And he studies them. And many of them are indigenous and they're forest dependent bees. Like the melipona. This is a native forest dependent bee. It produces a high value medicinal honey. This is $100 worth on Etsy. And it's connected to Mayan culture and traditional agriculture. These are jabones, so these are log hives. So the melipona used to live in hollow cavities in trees, and the Mayans would just cut that out, and that was the hive. So what they do now is they just cut logs and they draw the bees in instead of having to cut the trees down. Then they plug up the ends with these wooden dowels, and then they open them up to get the honey out. And then this is a melipona sticking its head out of the little hole. It's kind of sits there like a sentry watching. They do bite a little bit with their pincers, but they don't sting. Now there's concern about the extinction of the melipona and this traditional way of beekeeping and the loss of this special honey because of loss of forests. And again, this is actually why I was brought down to be an expert on forest conservation and things like that, because they didn't have anyone looking at that. People are now using these non-traditional hives, which are easy to open up, and trying to keep this going. So Dr. Herrera has his colleagues have this excellent manual for mangrove restoration, all kinds of different approaches they're using. This is you're building little islands. So the hydrology was messed up here. So what they're doing is building little islands to try to accelerate the development of these little islands. This is basically just digging trenches to reconnect the hydrology. This is where a hurricane came through and ripped all the leaves off of the mangroves. He has an army of mujeres, army of women volunteers who are doing these projects. A lot of them are the wives of fishermen who live in these coastal communities. They have to live among the mangroves. So his approach to conservation is to work directly with the communities. You can see that some of the communities have formed their own cooperatives, mostly for ecotourism like bird tours. But we were looking for something different that could be added in here to increase the value of the mangrove system in an analog forestry context without really interfering with the structure and function of the restored mangroves. So what we're starting is mangrove honey production to enhance native bee habitat and add economic value to the forests, both food and medicine. There's quite a bit of evidence that some of these stingless bees have really interesting medicinal qualities in the honey. So we weren't going to use the Africanized bees. They're not native. And they sting. Interesting, ecologically, you know, in a mangrove system, everything is constantly being assaulted with salt. And so all parts of the plant excrete salt. So the nectar is salty. So bees that feed on that nectar or gather that pollen actually have to be salt tolerant. Well, it turns out our little forest friend, the melipona, can drink salty nectar. This was the original idea. We were going to put the melipona into the mangrove forest. Oh, well. But then there's this little bee, Sakshik in Mayan. This little bee produces these bizarre, I don't know, they're like almost like Escher-like colonies. And it's found, I mean, I saw it myself. I saw them flying around on the black mangroves, Avicennia. So we have this opportunity to introduce them into this, very similar to what we're doing with the orchid bees, into these mangrove systems. We started a pilot project in Selam de Bravo, which is here. This is, there's a huge federal and state mangrove reserve here. It's all kinds of interesting things going on there. They put in camera traps and found out that there were jaguars living in there. Sinvistav, my partner, has mangrove restoration projects there already, and the communities are already involved in mangrove conservation there. Here's our group here. That's Dr. Herrera, and that's Dr. Quezada. So got the two of them together on this tour that we were here in just July of this year. This is all black mangrove in here. And this is the group of women volunteers who want to be involved in the mangrove honey project. So masks on down there. Dr. Herrera is explaining the mangrove system. This is the group of women. The women wanted, in the community, wanted the project to be for them only. They were very clear about that. So that's the way we're doing it. They didn't want the men handling the money yeah, so next Monday, in addition to the women who are coming from the other village to learn about the bees, these women are going to be transported to the workshop at the Yucatán University to learn about keeping this type of bee. So this is taking longer than I thought it would, but I'll just quickly go through what we're doing. So this is our research approach. We identify communities to work with, community workshops. We collect baseline ecological data. We do analog forestry training and treatments. We do system monitoring. And we're going to do community success monitoring and social choice experiments. And then synthesis and new learning. So I have a couple of years of funding now to go through this. We slowed down a little bit because of the pandemic. Got a mask on, but we just completed the community workshops this year. So an important part of this, and this is definitely outside of my traditional wheelhouse, is communication. So we created posters for both projects. The posters for this project were translated into Mayan, Spanish, and English. So this is in Mayan, and this is in Spanish. This is the miel de manglar, means mangrove honey, and that's vanilla of the jungle in Spanish underneath the Beatal way, which is Mayan. As you may, shout out to Lauren Cooper. Lauren Cooper took this whole carbon education program, forest carbon education program that she and I and others created, and converted it into Spanish with funding from USAID and Forest Service International programs. And so this created this Peru version, which basically everything was migrated into Spanish, but with an emphasis on some Peruvian ecosystems. I want to do the same thing, get more funding, and do this for create some content related to blue carbon mangroves and some of these other things in bilingual versions of the education videos. So what are the outcomes we're expecting? To engage and educate local communities about analog forestry, establish pilot research sites in community lands. We're almost there. Produce novel publishable results, social and ecological dimensions, and also proof of concept data. I don't have anything to show you yet. Enhance important international partnerships with Mexican research institutions, doing well there. And ultimately provide communities with new sources of income from forests to help conserve them. I'll just cover one more thing. While I was down there, I'm staying in the city of Merida. Now, the Yucatan is very hot and has a long dry season, so it's a very hot city. This is Merida, where their kind of base of operations are. You can see this metropolitan area is expanding. The Yucatan is, Mexico is a country that's a lot of violence and crime. The Yucatan is the safest state in Mexico, so what's happening is a lot of people are moving there. That's sort of fueling some of the development and growth there. So Merida is expanding, but it's a very hot city. While I was down there in July, I attended Cruzada Forestal, where they planted 15,000 native trees around the city. These were fantastic. This is the best organized community tree planting I've ever seen in my life. And so now I'm sort of giving some urban forestry expertise to the city of Merida, Merida Nos Une, and also work the Government Office of Sustainability as our partner. They're interested in not only the vanilla and the mangrove honey research, but they also created the state nursery that grew all of the native trees that are being used in these plantings. Now, Georgios and I published this really interesting paper, was it last year, the year before, in ecological applications. What this shows is basically the drought tolerance of trees relates to the architecture of their crowns. So all these different species have kind of different branching architectures and different shapes. So in addition to sort of creating some, giving some expertise to urban community forestry projects down there, I also see a long-term option to really study in this very drought susceptible and hot area, this pattern in another part of the world. These are from US cities where we found this pattern. So it's sort of doing a parallel study in actually a place where there's more extreme climate. Finally, I'm working on an education abroad course. I got an education abroad innovation grant from MSU. I'm going to bring students to the Yucatan to study what I call human forest mutualisms. There's going to be special emphasis in this course on sustainable forestry for promoting human well-being and connect with the medical study abroad, as I mentioned, connection between trees, bees, and forest foods and medicines, and forest conservation and climate change adaptation. So students will be getting to go around and visit all these different sites and connect with all these different people and experts I've been connecting with down there. It's going to align with the One Health concept of MSU's Institute for Global Health and UN goals for sustainable development. So they're sort of built into the course concept. And then one of my ideas is to actually pair MSU students with peers. We do this nice peer mentoring program in forestry here, and I thought it would be really cool to do this on an international basis with students from the University of the Yucatan. All right. So I left about 6 minutes for questions. Rich.
So that's really great stuff. And I love all the different components we have going on with it. And have you thought at all about kind of scaling up and how much contribution this potentially could make to the global vanilla market or global honey market? And the one criticism that often comes from more production-oriented agricultural systems is that small-scale farming really can't feed the world in the same way. And so, what are your thoughts?
Yeah, so that's fair. We don't have, so the group no one has the expectation. So Mexico's already a big producer of honeybee honey. And the people who are smaller artisanal producers don't ever believe that they will compete with big honey. As a matter of fact, the big honeybee honey producers got the melipona classified not as honey, so that kind of stuff. But anyway, the point of this is basically just to give a portion of the market to smaller communities. But, so for me, being somebody who works in forestry, sort of, it's like, how do we conserve forests? This is a vehicle to conserve forests by letting people have income associated with forested lands. So it's not just, it's not meant to be scaled to the part where it's going to be a huge piece of Mexico's contribution to world honey production. On the vanilla side, my personal sense of morality and history, I like the idea of bringing the vanilla back to Mexico, particularly the Yucatan. And that really shows a lot of promise as a forest conservation crop. And it has a very high value. So you don't need to produce, unlike honey, you don't need to produce a lot to make a significant income. So I think from a contribution to the scaling up perspective, the vanilla has a much bigger potential to make an impact at bigger scale than the artisanal honey does. But the mangrove honey would give some of these communities like just extra income. A lot of these people are living, very marginally. Like I can buy whole groups of people and have lunch with my per diem. You know what I mean? That's like my personal lunch pays for everybody's lunch. So, that's kind of what we're talking about for people's income differentials. So to me, it's like the forest conservation part of this is more important than the scaling up, but I think it's fair to say that this won't become a big share of Mexico's total contribution to world honey production. On the vanilla side, that could take off a bit faster. And the fact that it's organic and it's artisanal, there's some other things that could increase the value of it, at least on a per unit basis, if not on a volume basis.
So we have a question. So Ivan asked, regarding vanilla prices, with that crop being so valuable, is there a risk of farmers foregoing the milpa system to maximize vanilla systems?
Say that again?
So is there a risk of farmers foregoing milpa system to maximize profits from vanilla? Because the vanilla is so profitable, so has a very high prices.
So one of the ideas would be that they could do a little bit less subsistence farming and relying on food crop prices and have extra income from the vanilla. And so they could actually take a bigger chunk of the milpa system and put it in forest if they could get more short-term value. Because for the long-term values like growing trees for wood and things, it takes a longer time to realize it. They can start in year 3, they can start making money from vanilla after it's established. And vanilla actually lives a long time, can live for decades. So yeah, so when we talk to the people in Yaxina, it's a traditional Mayan community which has a milpa system, they loved the idea of the vanilla. Everyone in the village wanted us to hand out vanilla plants. I had to actually, through a translator, explain that we didn't come to hand out vanilla plants to people, but that's what they wanted. That's what they thought we were there for. So.
We had a question, but are we at time?
Yeah, we can go to one more.
Okay, so way back early on in the presentation, also, you had a slide that was looking at the different carbon storage placements of that carbon storage, and I just wondered, why was the teak plantation mining carbon storage? You could simplify that.
So we basically didn't test this directly, but in the discussion of the paper, we basically addressed we tried to address that issue, which was, so I didn't show the graph, but, so teak actually lowers the bulk density of the soil. And so that was measurable difference in the bulk density of the soil. And also, if you look at the picture of the teak plantation, basically what teak does is it drops all its leaves at once. It doesn't usually have much of an understory. And so a lot of, there's especially when heavy rains come down, there's an opportunity for erosion. So the combination of it changes the bulk density of the soil and carbon erosion, it just, the nature of the system seems to decrease the input. And so it appeared to be, based on the results, mining carbon out of the soil. And I found other papers, and then the discussion section added that basically showed others have found that teak is not good for the soil. And then for the analog system, there was good evidence that when you have higher biodiversity, you have these multi-layers, that you have this much healthier soil microbial community. And so not only do that facilitates more capture of carbon organic matter in the soil. And the one that surprised me was the degraded pasture had so much in it. And so there was this legacy of carbon from the previous forest and from, I guess, all the cows and the organic matter that was just sitting in there. So you did get a net amount of carbon capture from the teak plantation over the degraded pasture, but you really didn't do a lot for soil carbon sustainability. So this was a pretty interesting result, because that's a very, I mean, there's, lots of teak planted all over the world in these plantations.
So thank you so much, David.